Hello, welcome to the Exhausted Programmer. My name is Alexander, and today we're making a bash script. In previous videos, we showed how easy it is to run commands in the bash shell. In today's video, we want to take some of the things that we've learned and put them together so that we can start to automate some of the processes that we do on our computers. Today we'll just be making a simple bash script that's more just for looks and to show how easy it is. And in future videos, we'll make more complicated scripts that will do things like back up a home directory and manage our podcast for us, as well as other tasks. While this will be a Linux-focused development process, I do want to point out that I am running this actually on Windows. There is Ubuntu on Windows that you can get from Microsoft itself. Instructions to do so should be found online. I've done it 2 different ways since they first came out with this, and I'm pretty sure there's a 3rd way. So it might change in the future, which is why I don't want to focus on that for this video. But if you look up bash on Ubuntu on Windows, I'm sure you'll find the instructions from Microsoft. It's pretty straightforward both ways. It's just depending on what system they're trying to push it through, whether it's an app store or some sort of download on a website. Before starting any project, it's always good to start with an empty directory. So let's make a directory. We can call it whatever we want. I'm going to call it test because we're testing things out. I'll go to test and see that it is indeed empty. Now we want to create a bash script, and for a lot of people, you open a program first and then make something and then save it as whatever file format it needs to be. But here, it's important to understand that bash scripts start off as just simple text files. There are a number of text editors you can use. I will be using Vim, but if you want to use Nano, it's a pretty simplified text editor for the bash command. Emacs is what some people use, although I feel like that is not a good place to start if you don't know what you're doing. Similar with Vim. Both of those would probably need a tutorial to get going. You could also just open up this file in your Notepad on your Windows if you're running this like I am, or Notepad++ is another common simple text editor. What you do need to avoid is things like word processors, Microsoft Word, Google Docs, those kind of things. For this first script, we're going to want it to just put a message on screen. We saw in a previous video how there's this command called echo where we can type in hello, and when we hit enter, it will put that to the screen. How do we do this as a bash script? Well, let's just create the script. I'm going to call it message.sh. .sh is a common extension for shell scripts. The extension really doesn't matter because it's all on how you execute it, but this is what I use. Once inside, you just need to put in the command you want to run, which is the same as hello. We can save and quit, and then we can run this by running bash. And we see that we get the same thing. This might not be the best way to execute bash scripts going forward, so let's start with that first. File permissions is something we can take a deep dive into, but for the sake of this video, it's just important to understand that there's a way of marking files as being executable or not. And currently, message is not executable. It's just read and writable for certain people and readable for everyone else. To make this executable, it's pretty simple. The owner of the file, which is me, can run chmod and just say +x and the file. And now if we take a look at that same command, we shall see this X here. X is short for executable. The thing is it's still not quite executable just because we said so, but we can get tab completion with the // and then start typing it. And look, it does run, but this isn't considered best practices because you might have multiple shells running on your system, or you might be trying to run this from a different shell is really the issue. So it's important for us to tell it which shell we expect it to use, and then it will run on that, at least from my understanding with Linux executions. I don't actually know if Windows and Macs looks at the same things or not. That might be worth exploring at some future date. So how do we tell this bash shell which shell we want to run the message program under? And we can do that by opening it up. And at the very top, you might have seen this before, is this little line. The number sign, the exclamation mark, /bin/bash. And what exactly does that mean? Well, actually, if we get out of here, we can actually see that there is something called our root directory, and in there is the bin directory. with a lot of stuff in there. But if we look for bash, sure enough, that program exists. So when we run this, it says, hey, look for bin bash as a file to execute this following script. Again, this is something that I don't exactly know who monitors it and who makes it happen. As we saw, it wasn't necessary since we were running this in bash, but it helps to protect it in the future if for some reason another shell becomes more popular, or it helps to guide the user to know which shell is expected in case this causes errors in a different shell. And just to really throw it out there, yes, in my own personal experiences, I have seen situations where trying to execute a file didn't work because the shell that it was trying to execute under, even though I was in bash, was not bash itself. It was just shell, the even older shell that bash is based on. So with that ounce of prevention, we can continue on. We might want to send out more lines, which we can do, and then we can just run it and see our 2 lines there. It puts a new line in there for us, which is nice. If you don't want that, you can always look at the man pages to see if there's something that will disable the new line, such as -n, do not output the trailing new line. But little settings like that is for personal use. Just saying, if you want to try something that I'm not doing, start with the man pages. When you're writing your script, it's important to know what you're trying to achieve. And the next goal for this script is not just to put out a message, but to make that message look better. And we can do that with a program called Figlet. Figlet we can run, but it won't do anything by itself. Instead, if we give it a message, it will make that message look prettier. We can look inside the man pages to see that there's a lot of information about fonts and formats. Again, we're not going to go into all that, but if you want to do more with this, that's a good place to start. So let's go ahead and make this message script work a little bit better. Let's clear the screen. Let's go into message. And if instead of hello world, let's go back to just hello. Again, we can do Figlet. And I don't think you need the quotes. And there you go. We have hello written in that bubbly text format. So technically we have our script, but maybe we want it to do something more. Another thing I want to look at is date. Again, I'm pretty sure we looked at this in a previous video, but real quickly, if we run it, we get the date, including the time and time zone and all that. If we want to give it some commands, we can give it this command to get just the time. And then if we take that and we gave it to Figlet, it would give us a clock, but a bubbly clock. And here we got to introduce something new, and it's called piping. We can take the output, which would be the time, and pass it directly into another command. And in this case, we're going to pass it to Figlet. So using a pipe, which is shift backspace, that is the slash above the enter key on my keyboard, but I know there's other keyboard layouts. We can try giving that to Figlet. And there we go. The time in a bubbly format. We can continue to improve the format on this. Figlet gives us options like to center the text. And then also I have this T, which will make the centering a little bit better. It has something to do with figuring out the width of the text before it prints it. And again, that helps with making the centering work better. But of course, these aren't in our script. So let's put them in our script. We can come down here and we can just put the command just as we had it. The date with that, and piped it into Figlet with the commands TC. And then when we run that, we have the script running. And now we can just, anytime we want to get the clock and a nice centered bubbly text, we can just run our script. But we can still do a little bit more to make this a little bit nicer. The next command to look at is called watch. What watch can do, and we'll just give it a simple command. We can see that when we run it on the date command, every 2 seconds it will run date, and every 2 seconds this will update. So there we go. We can quit out of it with Control C. Let's clear our screen, and let's try to combine that with what we were looking at before. To get it working with what we have before, again, we can look at some man pages. find that we can actually adjust the interval, which is defaults to 2 seconds, but we can make it 1 second. We can make it 10 seconds. Again, depending on use, I'm going to go with 1 second. And then we're also going to use the T, because without it, you get this title bar. But if you give it the T flag, it gets rid of the title bar and just gives us the output text. And again, that plus the 1 second means it will update every second. Now, from earlier in the video, you might think the easy way to make this work with bubble letters is to pass it into the Figlet command. We'll give it the same flags to maintain consistency, but our output will be something unexpected. We see it tries the bubble letters, but it's just not looking correct. So let's Control C out of this. Let's clear our screen and try to figure out how we can fix this. Now, the problem does come down to a sort of order of operations. If you remember back in math, when you had parentheses and multiplications and subtractions and how you had to do everything in the right order, we have a similar problem here. The thing is that Watch will try to run this program and feed its data into Figlet continuously, like a constant stream. Instead, we want Watch to run this every second. So we can fix that simply with using quotation marks. And when we do that, we see that it is running the date format in the bubble letters. Of course, we want to get rid of the date and all that. I managed to forget this command from earlier, or this flag from earlier. And so if we add that in there, we get problems. And that is because it's not minus, it is plus. And there we go. Now we have a centered bubble text clock with no extra headers telling us that Watch is running it and how often it is running it, which wouldn't be a big deal, but it is a little bit cleaner this way. We can get out with a Control C, we can clear our screen, and now we can add it to our script. And honestly, this is a perfect time to turn something into a script. Instead of having to remember the Watch, its flags and arguments, and the Figlet and its flags and arguments, and the date and its flags and arguments, on and on. Instead, we can just run this one command and just have it all there. Also in the future, this can also work as a sort of documentation, because you're like, wait, what was the program that made the bubble letters? You can look at previous scripts to figure it out. So let's go ahead and add in what we've already done, which is to make this run every second, quotation marks to avoid the order of operations problem that we had earlier. And let's see, did we do it right? We did. Control C, clear, and one more improvement. A clock is nice, but there's a lot of programs that can run clocks. What if we could add a message to our clock? So let's go in there, and we can make it a bit on the ugly side by first telling it to echo a message before the date. So again, as we did before, which is to add echo hello, and then we can pipe that into Figlet, give it the same commands, and then we can give it this semicolon. This just tells Bash that this is the end of one command, and this is sort of like a new line. The reason why we use it here is so that we can maintain these quotation marks for Watch, plus this line isn't that long, so it's not too bad. You might want to add in a space to make it clear that these two commands aren't together. That is just an option. It's all about readability at that point. We save and quit, and we run message. We see our message, hello, and then the clock. But what if we want to change that message? Well, let's make that a little bit easier as well. When changing the message, the easiest thing to do is to make that change in a simple place to find in the script. So if we go in here, we see this command echo hello, but what if we could give it the message we want it to say up here, and then we can use it down below. Well, to do that with Bash, it's pretty simple. Type in your variable name and an equal sign, and then we'll put in be back in 5. And then we can change this to use that variable. Establishing variables in Bash does have some some rules to it. We can dive into that in the future, but no spaces between the equals and the variable name. And then I also don't put a space on the other side. I'm not sure at this point if that's because it can't have a space or if that's just because of readability, but we can stick to this format. Now, if we run our message, we see that the message is there. And if we do want to change the message, instead of having to come into this echo and finding it, we can just change it right here. Real quick while we are here, let's just go ahead and see what happens if we put a space before the equal sign. We see that message context changes. That should tell us that something's going to go wrong. And again, the message doesn't work. If we Control C, we actually see the error. It's looking for a command name message. Putting the equal sign right beside it is how Bash knows that that is not a command, but a variable that we are defining. If we put the space after it, it doesn't work. And again, we can get out. Be back in 5, command not found. Again, something that could be resolved by just making sure there are no spaces. So both of those spaces are problems. Neither are options. They cannot exist for this to run. So hey, I'm learning something too. Let's clear our screen and make yet one last improvement. Before we make the final improvement, let's understand that we can feed in a message if we want to. If we go into message, there is a command that allows us to read input. So instead of having this here, what we can do is tell it to read, give it a prompt. We're going to say we want the message, and then let's put in a space for readability, and then we can tell it where to store this. We can do that, get rid of that. Now, if we run message, it asks us what the message will be. Still not done, and we can see that that is there. The problem with this, I would say, is that maybe you don't want a message, or maybe you don't want to come up with a message every time you run this, but you still want there to be one, so you don't get this blank spot at the top. So the final thing that we'll use is to prompt for a message, and if none is given, we can just default to a standard message. So the first thing we need to do is to go into our message, and we'll have this prompt here, but we need to see if anything was provided. There are if commands that we can use. This will see if the message variable is 0. If it is, that means the user did not provide anything when they ran this program. And so we can tell it that message should be right back. But if something was provided, it will give that instead. Then we need to tell Bash that we're done with our if logic. And for readability, I am going to space these out. So this is an if block. If message is empty, again, evaluates to 0. It will set the variable to be right back. But if there is something there, it will just skip this line and go on to here. So we can do message, and we say hello, and we have a problem. And that problem is because I forgot to tell it to actually run, to tell it what to run if the if statement is true, that is, that message is empty, we need the then statement. It's just a little thing I forgot. Most programming languages just use syntax or parentheses, but that's not important for this video. So we can give it hello, or if we're just lazy, we can just hit enter and it'll give us be right back. If there is a default message though, we want to make that clear to the user. And so something I've noticed in other programs that I emulate in my bash scripts, if there is a default option, I put it into square brackets. You, again, will see this a lot of times with yes or no questions in a shell, where one of the letters might be in a square bracket. That means if you don't hit anything, that's what you're going to get. So we do this, and it tells me that if I hit enter, be right back will be put in there. But if I type in something, it will put that in there instead. Maybe you like this script and maybe you like the idea of being able to change the message, but to be able to type it out after you run it might be a problem. Maybe you want to put this on some sort of timer, which we definitely will look at in the future for this to run at a certain time. But you want to give it the message at the time it is executed. There's one more thing that we can look at, and that is arguments. We've already dealt with arguments in this video when we looked at watch and we gave it the flag in and the number 1. These are arguments that are being passed into watch that it can adjust its logic based on what we provide. We can do the same thing with bash scripts. So if we go into message, we can see if an argument was provided pretty simply by looking at the $1 variable. So really quickly, how does this work? Well, we can just test it out real quick by just echoing what is being passed in here. And if we run message and we say help, of course we are going to get the clock, but if we wait a second, we can see that it echoed it before it prompted us for our message. And if we look at our script, that makes sense because we're telling it to do that before we're asking for input from the user. But instead of just printing it out there, we can use it in our logic. Similar to the if statement below, we can actually say if this is equal to 0, do something. And I need to put this in parentheses, quotation marks. We can do this. Don't forget the then this time. I am going to put this more into the format that I prefer, which is 2 spaces for bash scripts. I don't know why, I just do. But what we can say is if this evaluates to 0, then prompt for message. But if we have a message, then we do not need to prompt for a message. Of course, if we do give it a message and then we don't ask for one, we are going to have a problem down here, but we will fix that in just a second. But we can do the same thing. If no message is provided, do what we did before, which is to then prompt for a message, see if one was provided. If not, default. And then if it was provided at that point, but not at the beginning, we can run it like before. But if we do have an argument given, we can instead run this else. And what this does is if this is true, run this, else it will run what's below. So it'll only do one or the other. And we can actually make this work pretty easily by, instead of running this with message, all we need to do is run it with the 1. And then we also, again, need to tell it that we're done with this if statement logic. So this goes with this, and this is where indentation really shows its functionality for readability. They line up, and these two line up. Now, they go together not because they line up, but because the first closing statement this comes across after it starts is this one. We line it up for our readability sake, not for the program's sake. We can save and quit, and then run our message. We can give it a message here and see that that works. We can not give it a message here and see that it asks us for something. If we don't give it anything, it will default. And if we do give it something, it will give us that instead. And all of that with just 13 lines of code, 12 really, 10, pretty small is what I'm trying to get at. Again, with readability, you might want to put that there, but it's not really much you need to do here. A script this small is pretty easy to read. Also worth pointing out is that this is not 80 columns wide, so we don't have to worry about breaking across lines. That is something that I would strongly suggest to anyone who is writing programming, but again, it's sort of outside the scope of this video. And with that, we can now have a message programming that we can just run like that. Today's video was not intended to be an exhaustive look at bash scripting, but to show you how even with a few simple commands, we can combine them together to create something new and functional. This script specifically was written a long time ago in order for me to set up for live streaming if I was ever to plan on doing it myself, which is still might happen in the cards. Something like this would be very helpful as a lead-in, something to fill the screen until the stream is ready to begin. So it could be very functional for me in that regard and for you for any number of reasons. You could have it running before a meeting as a way of just showing people something to look at and keep their interest, to add a little flair to something so boring as corporate meetings. Future scripts that we will look at is like a home backup script, something that I use every day and something that is very functional, very useful, and something you can take to make your lives better and to make data restoration a lot easier. I will look into even more options with that video. And so this video acts as a nice introduction to that. If you have any questions about this video or any other video covered on this channel, please feel free to leave comments below. If you have any ideas for topics you want covered, again, you can drop that below as well. Like and subscribe if that's your thing, and thank you for watching.